Good day to all you young grade 10 geographers out there, and welcome to our telematic broadcast. Now, today we are going to have a look at a revision for you for geography. We are going to have a look at most of the work that we have done in the first quarter. Now, obviously, it's going to be impossible in this short space of time that I've got available to cover everything in this revision broadcast. But I promise you, I will cover most of the work, most of the difficult work that we know you struggle with, and most of the popular work that you actually will see in the exams. Now, it's very important that when you have a look at our what we're going to do today, then you will have to see that what is our purpose of this revision today. Now, okay, firstly, remember that this is a revision, it's not teaching. Okay, that doesn't mean that I'm not going to teach a few of the difficult concepts, but the first and the foremost thing is that this is a revision session. Secondly, all the term 1 topics, only term 1 topics will be covered here. We are also going to have a look on to how to study certain things when it comes to the first term, and it's very important that we will go with this way in which we are, the way in which I'm working with you now we will go right through for all 3 revision sessions with you. Then I'm going to unpack and discuss questions. There are many types of questions that you can that will appear in your geography examination, and we will try in our 3 contact sessions that we've got with you, that we will try and unpack all of these different type of questions for your geography exam. Then, very important, integration with Mapwork. Even this, our in climatology, the atmosphere that we are going to do today, we must know that, remember, geography, the most important tool of a geography is a map. And we are going to integrate as far as possible. We are going to integrate with maps. Remember that when you get up to grade 12, then you must be able to integrate your content with your map book already. And it will be a good idea if we start as early as grade 10 to do so. And then what's very important is that the lessons during the course of this week, we will also share a poster with you on which you can just click on your phone, and the lessons and will appear on the phone. So this is very, very important. I would like to start off with something very important, namely questions that geographers ask. Now, I'm merely going to introduce you to this morning, and as we move through the year, we will really have a look at the questions geographers ask. Now, you guys, I see you as young geographers. Now, what's very important is that you must be able to think like a geographer. Now, imagine you are in a position to think like a geographer, and you know what's going on in my brain. And remember, I'm a geographer. Your teacher is going to set you the question paper. They're all geographers, and you must know, how do these people think? How do we think? If you know how we think, you can anticipate some of the questions that can go, you can see in the exams. Now, let's have a look at the questions that geographers ask, and this is very important. The first question that we ask is, what is it? The second question, where is it? The third question, why is it there? Fourth question, what does it look like? Then, what happened? What is the impact? And the last question, how can it be managed? And it's interesting, if you look at these questions, these first 3 questions, usually, the first 4 actually, are more your lower to medium order questions, right? You know that in the exams you can get the question like for instance, identify the cloud types. Now, you've done cloud types already. Then they can ask, but where do we find that? Is it low, medium, or high? Why is it there? What does it look like? You must be able to describe it, right? How was it formed? How did it happen? Right? What is the impact? We're going to have a look at global warming, for instance, today. What is the impact of it? and how can it be managed, the last question that we asked. Now, as I said, I'm just introducing you to these questions in order for you, to make it possible for you to think like a geographer and think and prepare yourselves with regard to these questions. You know, you can take any topic in your geography and you will be able to study by means of these questions. You know, in geography, you're not going to get a question where you will have to write everything, say a page and a half, 2 pages of something. No ways you're going to get that. The maximum marks allocated in the geography question, 8 marks. 4 times 2 for a paragraph type question. So you can't go and study pages and pages of geography. You must study with this in mind. Now, as I said, I've just introduced it to you. As we go throughout the year, in every one of our revisions, I'm going to come back to this and I'm going to apply it as we progress through the year. The next thing is very important, grade 10s. And this has to do with the types of data used in your geography exams. Now, the majority of the questions in your exams will be data response questions. Very important. Now, what type of data is used in your data response questions? Right. We use maps. I want you to think about this. Think what you received this quarter. Think what you have done last year. Maps, then diagrams or sketches. We will have case studies, very important. Statistics or graphs, and then infographics. Now today I am going to spend some time with infographics because it's so important. You know, the grade 12 examination is leaning towards infographics, and it's a good idea that you in grade 10 already should know how infographics works and how I must approach a question when I have been confronted with an infographic. More about that later. And the last one that they can type of data they can use is of course your cartoons. Now it's very important you know that you must be able to apply your content that you have studied over this quarter, over the year, over the phase. You must be able to apply on all these different things that I have mentioned to you, on the maps, on the diagrams, the case studies, the statistics, the infographics, and the cartoons. Very important that you must be in a position to do that. Okay, now, what are we going to do today? Let's have a look at our content that we are going to do today. Now, in this first quarter, you have done the atmosphere, right? Now, there are basically 4 things that you looked at: the composition and structure of the atmosphere, the heating of the atmosphere, moisture in the atmosphere, and synoptic weather maps. That's in a nutshell the content that you have done this quarter. Now, as I've mentioned here in my introduction, there's no ways that I will be able to cover everything in the short space of time that we have here, but the most important things will be done. Okay, so this is the content. Now, the first topic that we are going to have a look at is the composition and the structure of the atmosphere. The composition and the structure of the atmosphere. But before we get to the composition and the structure of the atmosphere, you must know why the atmosphere is so important for us. Now let's have a look. Why is it so important for us? It's important because it's a source of climate and weather for us. It moderates the temperature of the earth. It protects us from the harmful ultraviolet sun rays. The water vapor in the atmosphere gives us rain and moisture, and it provides us with gases needed for life. Now that is why the atmosphere is so important. Now you know why it's important. Now, what does it look like? What does the atmosphere look like? Now, you know that the atmosphere, of course, is that air that surrounds the earth. Now, let's have a look at this. You must know that in our atmosphere, we have basically these following layers: the troposphere, the stratosphere, the mesosphere, and the thermosphere. Those are the 4 main layers of our atmosphere. Now, when you look at the troposphere and the stratosphere, we have the tropopause, which is the upper layer of the troposphere as it moves into the stratosphere. Then the stratosphere, you've guessed it, and the mesosphere, the mesospore. So easy is this. So all you have to do is look at the layer, the atmospheric layer, and add pause to it, and you will get to the right layer, as it moves into the following layer. Now, what's very important is that you must know the characteristics of all of these layers. Now, let's have a look at that. Firstly, let's start at the most important one. This is the troposphere. That is where we live. It's a lowest layer. And it's so important for us. There we get the water vapor, the moisture. That is why clouds can form. That's why rain can form them. Right? And what's very important is the temperature drops. The higher you go, as you increase in altitude, the temperature drops. Hang on with that. We're coming back to that later on. Then the stratosphere. The important thing is that we've got an increase in temperature. It contains ozone, and it absorbs the ultraviolet radiation from the sun rays, very dangerous rays. And then the mesosphere, the temperature drops there to about minus 80 degrees, and we sometimes get very strong winds there. And the last one, the upper one, is the layer of the atmosphere is called the thermosphere. Thermosphere, as you can see, temperature. There's where the name comes from. Temperature rises to 1,500 degrees Celsius. Now, grade 10s, remember, you must know the characteristics of all these layers. But what's also important, in this, I've also shown you what happens to the temperature, and that's very important. So let's just have a look at the temperature in the temperature curve of the atmosphere. And that is very interesting. Exactly the same things that I've mentioned here. In the troposphere, look at that, decrease in temperature, right? In the stratosphere, increase in temperature. Mesosphere, decrease, and the thermosphere again, an increase, as we've heard, to about 1,500 degrees Celsius. Then, remember, the atmosphere consists of gases. And the most important gases that we find them are nitrogen, 78%, oxygen, 21%, and other gases that make up 1% of the atmosphere. Now, between the troposphere and the stratosphere here, we get our ozone layer. Now, that ozone layer, of course, protects us. So, let's have a look at this area called the ozone layer here. Now, firstly, what is the ozone layer? Here you can see where we find it. There's a troposphere, the stratosphere. Here we've got what is the ozone layer. Remember, the ozone is a gas. It forms a layer in the stratosphere, and it absorbs ultraviolet radiation. Very important. But now we've got the problem that the ozone layer, sometime it was really depleted. Now, what's happening there? Why did it deplete? It's because of the chemicals that we find there, chemicals like your CFCs. And what is the effects of the ozone depletion? Remember, if that ozone depletes, what's going to happen? What's going to happen is that these dangerous sun rays can penetrate, and it can reach our skin. So what we've got here is the effects. We've got skin cancer, eye cataracts, and the photosynthesis that can be disrupted. Now, what can be done? I just want to show you before I proceed. Remember, in my introduction, I have mentioned the questions that geographers ask. Now, here you can immediately see a few of the questions. Here, what is it? Right? What happened? It started to deplete. What is the effect? Can you remember those questions that I've asked earlier? And then, how can it be managed? How can it be reduced? Of course, it will be that the chemicals must be banned. CFCs are banned at the moment. And limit traveling by car. Because Ka is, is one of the biggest sinners of our earth here. The gases given off by the processes, burning process of the car, you've got a problem with that. And then avoid the pesticides and fertilizers. All these things actually have a problem that it can deplete the ozone layer. Now that, in short, grade 10s, that concludes our first one. That has to do with the layers of the atmosphere and what's going on in the atmosphere. Now, what should you know, right? You must know this when you study this section. Firstly, why is the atmosphere important? Secondly, what gases are found in the atmosphere? Thirdly, what are the names of all the layers of the atmosphere? What are the characteristics of each layer? The temperature changes in each layer? What is the ozone layer? What are the causes of ozone depletion? And how can this be reduced? These are the things that you must know. This summarizes the first content chapter that we had in the atmosphere for the first quarter. Now, the second chapter dealt with the heating of the atmosphere. And this is very important. The heating of the atmosphere is the core of your grade 10 syllabus, as you will see as I proceed through this content now. The first thing that you must know, grade 10s, is that 100% of sun energy is coming towards the earth, 100%. But not all of the energy reaches us. Now, we are going to have a look at the process now that is associated with the heating of the atmosphere. Let's see what happens with this energy. Firstly, 70% is reflected by clouds. 8% reflected by atmospheric gases and dust. 23% is absorbed by the atmosphere, 4% by clouds, and 19% by water, vapor, gases, and dust. That leaves us with 52. Then 6% is reflected by the Earth's surface. And then we're only left with 46% that actually reaches Earth. Now, that 46%, that is the percentage that is responsible for the factors that affect temperature. This is very, very important. This part that I'm going to do with you now, grade 10s, you will receive at least one 15-mark question of one of these factors. At least one question of one of these factors. Sometimes it can be combined. But please, this section that I'm busy with, you must study. There's a 15 marks for you now available for your test now in March as well as the end of the year. Okay, let's have a look at this. What factors actually affect temperature? Now, there are 4 of these factors. Let me just mention them to you. The first factor is latitude. That is the distance in degrees north and south of the equator. Secondly, altitude, height. Thirdly, the distance from the oceans. And lastly, your ocean currents. Now, these are the factors that affect the distribution of temperature. And we are going to have a look at each one of these now. How does each one of these factors work, and how do they affect temperature? Does it get cooler, colder? Does it get warmer? Let's have a look. The first one that we are going to have a look at has to do with latitude. And as I've mentioned to you, latitude has to do with the distance in degrees north and south of the equator. Now, let's have a look at this. Let me first explain this diagram to you. Here we've got Earth. Here's the equator, right? This is the sun over here. And here we've got the sun rays coming in through to the earth. Now, to understand this, to know this, to interpret this, you must understand what happens here with the energy coming towards Earth. Now, let's have a look at what happens. We have a difference in what's happening in the equator and at the poles. So let's see what's happening. Firstly, just have a look at this. You will notice that here we've got the smaller volume of air at the equator, and have a look at the poles. We've got a larger volume of air. Now, what's happening here? Remember that in our previous slides, I showed you things like what can happen. Absorption can happen. Reflection can happen. Now, imagine that you've got a large volume of air and a smaller volume of air. This means that here we'll have more absorption, we'll have more reflection, as well as in the South Pole. Here at the equator, we'll have less absorption and we'll have less reflection. Now, let's have a look at the second thing that happens. Firstly, here in the poles, you will see that the energy is spread over a larger area. And at the equator, it is spread over a smaller area. Have a look at these dotted lines that I've drawn here and over here. Because you can see that the angle at which it strikes here at the poles means that the energy spread will be over a larger area than at the equator. And that is very important. Now, because of all this, it happens that it is so that it's warmer at the equator than at the polar areas. This is very, very important. Now, grade 10s, when you study this, please don't go and take a page and write down everything. Study the way in which I've presented you. Draw the thing. You must think in diagrams. You must think in images. Because geography is a subject of images. So when you do something like the influence of latitude and on temperature, and you are only going to write out how many 4 or 5 things and say, now I know it. It's not going to work, because that's not the way in which it's going to be examined. If they're going to ask you the influence of latitude on temperature, your teacher is going to give you the diagram of the position of the earth and the sun and the different energy coming towards the earth. And you must be able to think about that. You must be able to explain all these things. So please think in images, think in diagrams. Don't only study and write down certain things. Because geography, diagrams, very, very, very important. Okay, so that was the first one, the influence of latitude on temperature. That's not all that happens. We also have the influence of altitude on temperature. What is altitude? Means the higher you go, that's altitude. So let's have a look at this beautiful photo that I have here of Kilimanjaro. Now, if you have a look at this photo, you will notice that here the caps here of Kilimanjaro is covered in snow. But look at the valley here. Now, this is very important that you must understand this. This height is 5,895 meters above sea level. But look at this, Kilimanjaro is located on 3 degrees south. Now, if you must look at my previous explanation, we had to look at latitude. The first thing you're going to say, hang on, here's something wrong. How is it, you've just explained to me now, a few minutes ago, that the further you move away from the equator, the colder it gets. And here we've got the mountain with snow on. what's happening here. Let's see what's happening here. So what we've got here is this. We've got the height there. And here on top we find snow, and here in the valley we've got 23.3 degrees Celsius. So what you are actually experiencing here is that the higher you go, the colder it gets. Now, why? The reason, therefore, is the higher you go, the less carbon dioxide and water vapor you get, and there are no gases to absorb the heat. Where in the valleys, you have more carbon dioxide and water vapor to absorb the heat. And this is very, very important for you. You must know why does it become colder as I increase in height. So this is a very interesting thing. Now, if you look at this photo again, as I mentioned, there's a beautiful photo. We'll come back to global warming, and the problem is that these things are busy melting there on Kilimanjaro. But more about that later when we come to our global warming. Now, grade 10s, I've also told you in our introduction that it's very, very important that you must be able to apply what you have learned on your topographic map. Now, here we've got an opportunity to do so. And we're doing this as an example for you. Now, let's have a look at this map. Here we've got the map of Franschhoek. And the question here is, at which of the locations A or B would it be warmer? Give evidence from the map to support your answer. Now, the first thing that you will tell me, listen here, this is something to do with temperature. How can you test this on a map as a Mapwork question? We can. Remember, we are doing altitude. We are testing the influence of altitude on temperature. And you have just learned that as you increase in altitude, the colder it becomes. In other words, the higher you go, the colder it gets. Now, they want to know here, now, why? Which one is warmer, which one is colder? And we have give evidence of the map to support your answer. Now, have a look at the location, what's the location of A and B. A, you'll see, is in a valley. B, have a look at that. Brown. Now, grade 10s, you are starting to really work with topographic maps. And you should know that if I see brown, that means that there is a mountain. And you have done contours. And you should know that the closer the contours are spaced, the steeper the slope. And have a look at this here. So here we've got contours here, brown, right, close to each other. This is definitely a mountain. And look at A here. You really don't see any contours. So this here would be the valley, and that would be the mountain. Now, the height is given on the map here. Firstly, we've got a benchmark here. There's a benchmark 227.8 meters. That's the height of A. Now let's have a look at the height of B. 1,228.7 meters high. So this one is higher and that one is lower. So what we've got is the following. We've got an increase in height. In other words, it's going to be much colder here and it's going to be much warmer there. This one is on the mountain, this one is the valley. Think about the example that we had of Kilimanjaro. When we had a look at that photo, you definitely saw that on the mountains, because Kilimanjaro is so high above sea level, we saw snow on the mountain. The higher you go, the colder it gets. And in the valley, it was 6 degrees Celsius. So here in Franschhoek, we've got a similar issue going on here. Of course, which is not so high. as kilometers. So you won't. Yeah, in the winter you'll find some snow, of course, on these mountains here as well. But the most important thing is you must be able to identify where is the higher, where is the mountain, and then you must also be able to identify where is the valley, what is the height, and why we have the difference in temperature. So this is very important, right? So please remember that you can integrate, you must integrate your topographic map with your content where possible. Okay, so that concludes altitude. Let's have a look at the next one. The next factor that influences, that has an effect on temperature, has to do with the distance from the sea. The distance from the sea. I'm sure if you have visited the sea or whatever, you know that, okay, it's a bit colder here, especially on a hot day, you love going to the sea. But let's have a look at the impact on temperature and how it impacts temperature. The first thing that you must understand is that solids and fluids react totally different on temperature, on the heat of the sun. Let's see what happens here. Now, here we've got the sun, and here we've got the rays coming towards both the water surface, the sea, as well as the land. Now I want you to notice one very important thing. As these sun rays hits the land, only the top, the thin top layer, that is heated. But have a look at the sea. What happens now is that the seas penetrate deep into the ocean, the rays penetrate deep into the ocean. In other words, they've got a loss of heat here. That is why the water will be cooler than the land. Let's see what else happens. What's happened is that because of this, you need less energy to heat the surface than you need to heat the water, the sea in this case. The second thing that happens here is evaporation. As the process of evaporation takes place, heat is needed. This means we've got a loss of heat because the water is being evaporated here. And then the following thing that happens here is that the ocean circulates heat. That is impossible here on the land. Now, what you can do is if you take a pot of water and you boil the water, then you'll see most of these things, and it will be easy for you to understand. If you should heat a solid, say a piece of iron, and you heat water in a pot, then you're going to get about the same things happening here. All right? The iron will heat much faster, right? Because here we've got such a lot of, even if the water boils, you get this. You actually see the circulation of your heat needed here. So what's happening here now is that during the day, you will find that the sea is much cooler than the land. Now, what happens now? What happens now, the distance from the sea, the influence thereof, is that you have a maritime climate and you have a continental climate. Now, your maritime climate, you will have cooler summers because it's closer to the sea. You'll have warmer winters and a small temperature range. Temperature range is just a difference between the highest and the lowest. But look at this interesting thing, warmer winters. Why will you have warmer winters at the sea? You know why? Because water keeps its heat much longer. If you heat a solid and you heat a boiled water, and you come about 10 minutes later, and you'll be able to perhaps pick up the solid, but if you put your hand in the water, boy, you're going to burn, because the water keeps the heat much longer. Okay, that is why we've got much warmer winters. Now, your continental climate is where there's absolutely no influence from the sea. You can see this is very far from the sea, right? And the type of climate that we have there is hotter summers, but we've got colder winters. Why? Because there isn't a sea whose water will be warm and that can provide an increase in temperature. And then here, of course, we've got a larger temperature range. In other words, the difference between the highest and the lowest temperatures. What also happens is an interesting thing that I would just like to mention here to you, and that has to do with the occurrence of a sea breeze and a land breeze. Because of the difference in heating of the sea and the land, you will get that during the day you'll have a sea breeze, where the air flows, the wind blows from the sea to the land, and during the night you'll have a land breeze where the opposite happens, and the air flows from the land towards the sea. So there's interesting things that happen just because a sea is present there. Remember the difference in the maritime climate and the continental climate. Now, another interesting factor is the influence of ocean currents on temperature. Now, if we have a look at this map of South Africa that I have here, and here we've got 80 degrees Celsius here at the west coast, and we've got 24 here at the east coast. And the first thing you would tell me, hang on, you have just taught us a few minutes ago that have a look at this, they're the same latitude, so I mean they should be, they're the same distance from the equator, so the temperature should be about the same. Okay, you're correct, but remember there are other things that also factor in when it comes to temperature. High temperature or low temperature, warm or cold. So let's see what's happening here. Here we've got, of course, the warm Mozambique here, and here we've got the cold Benguela, and immediately it starts to make sense. It starts to make sense in this way that we've got cold water here, which would, of course, have an influence on your coast here, and we've got cold water here, and here we've got warm water, which of course will warm the coastal regions of our east coast. So please, when you have a look at this grade 10s, remember that these things, these temperatures that I've talked about, the factors influencing temperature, can also be tested from your synoptic weather map. All right? I'm going to do that later on, because I must first explain to you and go through you what the synoptic weather map looks like. So hang on with this. We'll integrate this with the synoptic weather map when we get to the synoptic weather maps. Okay, so now we've looked at the factors influencing temperature. The next thing that we would like to have a look at is called the greenhouse effect. The greenhouse effect. Now, let's first see how does a greenhouse work? I mean, you know that the greenhouse, you've got your plants in the greenhouse, and how does it work? Now, what happens here is that the greenhouse captures the heat from the sun. There you see the heat coming through the greenhouse, and its glass traps the heat, and the plants inside remain warm. Now, the same thing, of course, you get, on a hot day when you get into a car, all right? When you get that the energy, the rays of the sun, the heat is trapped in the car, much warmer inside than outside. Exactly the same thing that happens. So this is what the greenhouse effect is all about. And this greenhouse, about the same thing happens to the earth. But now we don't have the earth in a glass box or whatever. Other ways in which the temperatures increase on earth happen. Now, what happens is, you must know there's something called greenhouse gases. These gases trap the energy, as we will see now. So these gases are the following. The greenhouse gases are CO2, ozone, CFCs, carbon monoxide. I'm just mentioning a few of them. Now these gases prevent the heat going away from leaving the earth as the same that the greenhouse does, right? It's trapped within the earth. So let's see. But what happens on the earth? Let's have a look at the greenhouse effect on earth. Now, here we've got the sun, here we've got the earth, and here's the sun's rays. The sun's rays heats the earth. This is the first thing that happens. So, what happens then? If you have greenhouse gases in the atmosphere, what's going to happen then is that this heat cannot escape and is trapped in the atmosphere. And the temperatures, and we have immediately, we have a rise in temperatures of the earth. And this thing has been going on for some time, years already. And what's happening now is devastating of the earth. So let's have a look at global warming that happens as a result of the greenhouse effect. Now, the first question is, but what is global warming? And this is very, very important. You know, global warming is the increase in the average temperature of the Earth's atmosphere. In other words, you've got an increase in temperature. Now the question is, why? Can you see? Cretins, let me just get back to this again. Can you see? I'm again busy with the questions that geographers asked. I told you in our introduction, I'm just going to introduce this to you, and as we carry on throughout the year, we'll come back and constantly come back to this. And here's another opportunity to do so. What is global warming? Can you remember the first question? What is it? Look at this. What happened? Right? So, why did it happen? Because of human activities that increases the greenhouse effect. More fossil fuels are burnt, and you actually causes also because of deforestation. Now, what's the consequences of that? The consequences, of course, you have your rise in temperature, the melting of the snow and ice. I've mentioned Kilimanjaro. As the ice caps melt, you could have a rise in sea levels, extreme weather, floods, desertification, and climate change. Now, let's have the impact. This is very important on Africa. Climate change. How does it impact Africa? You've got the shrinking of the tropical glaciers. That's Kilimanjaro then. The expanding of deserts. More about that in grade 11 next year. Drought and famine. Higher temperatures. And your food security that will be threatened. That's now the impact it has on Africa. Now, the most important question that geographers ask is what can be done? So here we go. Firstly, we must definitely regulate the emissions of the greenhouse gases, which is happening at the moment. We must move towards solar and wind power, sustainable transport. We must use energy efficiently, and, of course, regular discussions and strategies that to be done. Now, grade 10s, remember that this is what I've mentioned. There's something that you can also do, that you as a school can do. And you must figure out how you can reduce what is called your carbon footprint. What can you do to prevent global warming, to prevent the greenhouse effect, right? Think about that. See what you can do as a school, your contribution to your community, right? Remember, there's a geography saying that says, act locally, but impact globally. And that's exactly what you will do if you really try and do something to reduce your global warming. Very important. Now, this is an infographic of global warming. Now, let me first explain to you what's going on here now, grade 10s. You know, this comes from your tutoring book, with regard your revision booklet of geography for the first quarter. You will receive that during the course of this week. We will also put it on a poster for you, right? And you will be able, definitely, be on our e-portal. You will be able to access it. And this is one of the questions with regard to global warming. And I used an infographic on purpose because I wanted to give you, you know, these things, you must practice this stuff and you must understand this stuff, right? Before you can answer it. If you don't know how to deal with infographic, you can't get to the answers. So what I'm going to do now is we're going to have a look at, okay, we are going to have a look at the question, but the most important thing is that I'm going to show you how do you deal with infographics. This means, remember this is a revision, this means that the infographic anywhere from now till the end of the year that you get in any section of geography, you deal with it in exactly the same way. Global warming is merely an example that I'm using as an infographic. Okay, so let's have a look at this. The first thing that you must know is that an infographic is a collection of images, graphs or statistics and short text that gives an overview of a topic, of one topic. Have a look at this again. It gives you an overview of a topic. This whole infographic, the topic that it covers is global warming. But it's covered by means of a few things. Let us see what has happened. Firstly, an image is given to you, and the image is given by means of a cartoon. The second thing is the statistics. What do the statistics deal with? It's dealing with greenhouse gas contribution. These are the most important contributors to greenhouse gases. And then it has another third component, namely a short text. All right? Now, just have a look at the definition again. An infographic is a collection of images. We've got images. Yeah? We've got graphs. Yeah, on the cartoon there's a graph as well. Statistics. Here we've got statistics. And a short text also. There we've got that. It could be a photo also that's added. Anything with the same message of the same topic. In other words, global information. Infographic giving you information of one topic, namely global warming in this case. Now, what's very important, grade 10s, is you must know how to deal with infographics. If you have a look at this thing now, the first thing that you must do is that you must get an idea what the infographic as a whole is telling you. You can't just jump into this question. Grade 10s, you know, when you see an infographic, it's very important that you must use at least 5 minutes to have a look at that infographic before answering it. You must know what everything in that in the infographic means. What does the photo say? Is there a cartoon? What does the cartoon say? Is there a graph? What does the graph say? Is there any statistics there? What does it say? Remember, it all deals with one topic, and in this case, it has to do with global warming. Now, so you must get an idea what the infographic, the whole is telling you. It has to do with global warming. Then the second thing is, what are the different types of information given? Now, already in the previous slide showed you the different types of information given here. That we've got our cartoon here, we've got our written part here, we've got a few statistics that they've given here, right? And then, this is very important. when you deal with an infographic, read the written information first and then look at the other information. I'm just going to repeat that, grade 10s. When you deal with the infographic, read the written information first and then go to the rest, because it's going to give you a background. Then you'll immediately see, oh, this fits in here and that fits in there. Right. Next one. Look for links between the different types of information. Now here we've got three different types of information. Are here any links that you can see here? Let's have a look. Of course, right? Rising temperatures. There's a link between the first word there and the graph there. Look at this graph. It's rising temperatures are rising there. All right? Let's go further. Another link that we've got here. Increased greenhouse gases. And here we've got a link because this is these things are the greenhouse gases, the contribution of the different sources of greenhouse gases. So immediately, now you know what's going on. Now you have a mental image of the infographic. Grade 10, I cannot overemphasize this. When you deal with infographics, please, you must use 5 minutes to study the infographic, look at the links, establish what this is all about, and then after that, you can attempt the questions. Okay, now, here we've got the question. This is the same question that appears in the workbook that you will receive this week. But what's very important now, and this is the most important step of dealing with your infographic, is that you must know what information to use in the infographic. You know, if they ask you a question and you're looking at the wrong part of the infographic, you're not going to get to the answer. If they say quote from the infographic, then you must know, I've got to go to the text because they want the quotation there. All right? So it's very important that you must know what part of the information in the infographic must I use to get to the answer. Let's have a look at the questions. The first one is, what is global warming? Now that's just a plain definition, so you don't even need your infographic to get to the answer. You should know that. And what I'm not going to do, grade 10, as I've told you, this is going to be in your revision booklet that you will receive this week. I'm not going to give you the answers. I want you to go and do this. But all that I'm going to do is to show you how to get to the answers. But when it comes to that, you're on your own. Please go back to your teacher and work through this and ask him or listen, yeah, am I on the right track? Are these answers correct? Okay, let's have a look at this. The following one is, does the graph show a rise or drop in temperatures? So immediately they say, does the graph? So that means you must use that. There's a graph and you must establish, have we got a rise? Or is there a drop in the temperatures, upward tendency or downward tendency? Very important question when it comes to infographics as well as when it comes to graphs. Okay, next one. The man in the infographic mentions that we should stop burning stuff. To what stuff does he refer? Again, I'm not going to give you the answer. But here, you can immediately see this has to do with this man here. Looking at the graph, we have to stop burning stuff. What stuff? And you know what? And here's coming when you get to higher order, medium order, and lower order questions. Your lower order question, the answer will be on the infographic or any diagram or whatever that you do. But when you get to medium and your, especially higher order question, the more difficult questions, then the graph that you use or the infographic that you use, you must use that to connect to the content that you have studied. So let's have a look at this. What's very important that is we must stop burning stuff. So now you must know, but what did I learn there at what stuff is this guy talking about? And they're asking you there, to what stuff does he refer? Go and look in your booklet, go and look in your notes. You will be able to get to that answer. Right. Now, the next question. Give 2 changes mentioned in the infographic. Look at the question. Mentioned in the infographic. In other words, the answer is lying there. So have a look again. Give 2 changes mentioned in the infographic resulting from man's impact on the atmosphere. And if you read the first sentence, they say there, rising temperatures, higher sea levels, and polar ice melt are just some of the many changes. You had to mention any 2 of them. And the last question, they say, arrange the following from the smallest to the largest contributor to greenhouse gas, and that, of course, the answer you will find there. Transport, agriculture, and industry, you must look at the percentage contribution, and all you need to do is that you must arrange it from the largest, from the smallest to the largest contributor. Now, grade 10s, please remember, I on purpose didn't give you the answers here. But I've led you to all the answers because I want you to go to your book and go and do this exercise. It's very important that you do the exercises that we provide you and that your teacher also gives to you. Right? That's the only way to success in geography. So please do this and check up with your teachers for the correct answer. And this first infographic that I've done with you, I've taken a very simple one, and the questions that I set are also very low to middle order questions in order to give you an opportunity to understand how infographics work and to understand how to get to the answers. Okay, so for this section where we look at the heating of the atmosphere, you must know the following. Remember that at the end of every theme, I'm trying to tell you what you must know. So you must know this. The first thing, what processes are associated with the heating of the atmosphere? You must be able, and this is very important, explain the impact of the following factors on temperature: latitude, altitude, distance from the ocean, and ocean currents. Grade 10s, you are writing a control test now, soon. All right? Now, what's very important is that any one of these 4 can be examined. You will see it in your question papers. So please make sure that you study all 4. Please don't spot. All 4 are important. Right. Next thing that you must know. What is the greenhouse effect? What are the causes, impacts, and consequences of global warming? And then, of course, the management of global warming. What can be done? So grade 10, we have now completed the first 2 topics in our atmosphere. And the next one that we are going to have a look at deals with moisture in the atmosphere. And the 2 things that I've chosen to do the revision on with you would be the type of clouds and the different types of rainfall. That is the 2 things that we will have a look at. Okay, so the first thing that we are going to have a look at here would be your different types of clouds. Now, you know, grade 10s, geography is not what happens in the classroom. Geography is what happens out there. And when your teacher has done this lesson with you, the types of clouds, the first time that you saw clouds in the atmosphere, it had to ring a bell. And you should have attempted to say, okay, that looks to me like a cumulus cloud. or that looks to me like a cirrus cloud. Very important that you do that. And if you're not sure, go to your textbook, go to your notebook, your workbook, and look at the photos or the diagrams that they have of these clouds. All textbooks cover this. They have photos, they have diagrams of the clouds. If you're not sure, look at the photo. You will be able to get to the answer. That is when geography only starts to make sense. When you take your geography out of the classroom and identify the things that the teachers have taught you. So let's have a look at the types of clouds. Now, as I've said, there are quite a few different clouds. We are only going to have a look at a few of them. The first one will be the cirrus clouds. Now, these are your very thin feather-like clouds, usually fine weather. And when you see these clouds, you must know that a cold front, strong possibility that the cold front is approaching. Now that winter is coming, we're moving into the winter season after autumn. These things, we'll be able to see more of these things. Your cirrus cloud and then your cold front moving in. Okay, so that's the first one. The second one would be your cumulus cloud. Now, you know, if anybody asks you to draw a cloud, that's the one that you usually draw, right? Ask anybody. I ask you, you even ask a young child at primary school, listen, you draw a cloud, then they're going to do that, right? And that is your cumulus cloud. So your cumulus cloud, as they say there, looks like cotton wool and fine weather also that will be in when you see these clouds. Then your stratus clouds, they are flat layered clouds. They are uniform and grey, and your drizzle, light drizzle, you usually get slight drizzle you usually get from these clouds. And then your nimbo stratus, you know the word nimbo actually means rain. So what you've got here is, remember, here you've got nimbo. Here you've got cumulonimbus, coming back to that again. Layered clouds, a thick dark layer, heavy rainstorms. Remember, that was your nimbo stratus. And now you've got your cumulonimbus. These are your very tall, dark grey, the thunderstorms that we get. That's the cloud bringing it. It's the one, the hail, the lightning, your big, huge hail size of golf balls, right? That's the cloud that's responsible for your thunderstorms, your hail, and your lightning. So this is very important. See that you are in a position to identify the clouds and to give the characteristics of these different clouds. As I've mentioned, the two things that I've chosen to revise with you are the types of clouds and the types of rainfall that we're going to have a look at. Just to refer you back to your booklet, the revision booklet that you will receive. More detail you'll find there. You will also find other things also in there for that. Another thing in your booklet, nearly every one of the topics is accompanied by a QR code or a link. Okay, and that's very important that you must know that. Because if you do something like clouds, if you do something like global warming, all you need to do is take your phone, scan the QR code, and then a lovely documentary of that topic will pop up, right? Or follow the link, click on the link, will also take you to the same documentary. Very important. I've chosen of these video clips that are not longer than about 4, 5, 6 minutes. So everything can be covered, will be covered to you in a very short space of time, and you'll be able to understand it more. So please have a look at your video clips as well. Okay, now the types of rainfall that we are going to have a look at will be convectional rain, cyclonic rain, and relief rain. Those will be the types of rainfall that we are going to study now. Now, the first one is your conventional rain. And remember, you must be in a position to explain all of these rains, how they are formed. So what's happening here is that the sun heats the Earth's surface, the air rises, clouds form, condenses, and rain falls. Right? Now, condensation, remember, is when water vapor changes into to liquid water. Now, this is basically the type of rain that we get in the summer in our interior, in South Africa. The second one that we rainfall type that we would like to look at is your relief rain. Now, relief means you've got a mountain must be somewhere. Okay, so what happens is the following: that warm, moist air cools as it rises. Have a look at this. It's rising here, up the mountain there, and what happens then is that clouds form, and condensation, and then you've got the rainfalls. Now, what you've got here is the leeward side. That is the leeward side where the air descends there. That is usually dry. It can only mostly rain on this side, because what happens here, the air is actually forced up here, clouds form, and the windward side, your rain we do have on this side, and it would be dry on the other side, which is called the leeward side. The next one is your cyclonic rainfall. Now, what happens by cyclonic rainfall, what you must understand is that you've got a front here, this dotted red line here. A front is where you've got warm and a cold air mass, and where the two air masses touch or meet, that is called a front. Now, here we've got a warm air, cold air. See what happens, right? Remember that air masses don't mix. And what happens is that your air, warm air, it's lighter, and it rises over the colder, your dense air. And then you get heavy rainfall along the front. That's very important. Now, grade 10s, when it comes to cyclonic rain, see that you understand it. You must have a good understanding of that, because in grade 12, you will be doing the mid-latitude cycle. And then this that I've given to you now of cyclonic rainfall is a very simple explanation. There's much more than this, I can assure you. But if you don't understand the basis of this, which is this that I've given to you, there's no ways that you will understand in the grade 12. So please make good use of this information and try to understand your cyclonic rainfall. It will just make it for you much easier as you move through the FET phase. Now, again, as usual, at the end of this topic, let's see what you must know. Now, you must know this. What are the names of the different types of clouds? You must know that. What are the characteristics of the different types of clouds? What are the three types of rainfall? You must know that. Explain how conventional rain is formed. Rain is formed. How cyclonic rain is formed. How relief rain is formed. And then, do I know all the concepts? Now, here's a lot of concepts that accompanies this section of the work. All right? You must know concepts like evaporation, condensation, and all those type of stuff. Now, in your booklet, revision booklet, on the last page, we have given you all the concepts that appear in the atmosphere of the whole section of terms 1 work. Now, what we did was, we only gave you the concept, and you will have to go and write in the definition. You know, the only way that you can really learn is by writing something down. Okay? So we've left out that. You must go all this, and it's so important. I think you should get in the good habit now of studying your definitions. So many learners lose marks in grade 12, and I'm sure you're grade 10 and 11 as well, because they don't know and understand, and therefore cannot apply the different concepts, the different definitions of geography. Don't let that happen to you, right? Throughout the year, on our last page, We will give you all the concepts. You must go look it up, and you must physically write in the definition in the space that we have provided you. Okay, our last chapter, grade 10, deals with synoptic weather maps. Now, this is where everything comes together. You know, I love Mapwork so much, whether it's your topographic map, whether it's synoptic weather maps, because this, when it comes to this, it has to do with the application of the knowledge that you have learned in theory. And you know, so many things can be applied here on your synoptic weather map. So let us have a look. Firstly, you must know what it's all about. Before you can, you must know your, just like your topographic map, all right? There's no ways that you really can interpret if you don't know the key. You don't know the concepts that accompany the key. And here, in the synoptic weather map, is exactly the same. And that is why, before you can deal with your synoptic weather map, you must know the following. You must know that firstly, each weather station is shown by means of a circle where the cloud cover will be. And that cloud cover can be any one of this. It can be an eighth, it can be a quarter, half, it can be 3/4, it can be overcast, there can be nothing in there, in other words, fair weather, right? 0% cloud cover that you can have in them, right? That's the first thing you must know. You must know this, right? Then you must know that there are two numbers that will be given. The first one on top is the air temperature, and the one at the bottom is the dew point temperature. Now, grade 10s, please don't make this mistake. You see there's only written 18 and there's only written 16. Units are very important. Get into that habit as soon as possible, right? When they ask you distance, you must know kilometers, right? When they ask temperature, you must know degrees Celsius. So although here is only written 18, that's the way in which it's done on your weather station model, right? This is called the weather station model. This means if they ask you, what is the air temperature? Your answer must be, not should be, must be 18 degrees Celsius. Dew point, 16 degrees Celsius. If you don't add degrees Celsius, it's wrong. Even if you got the number correct. If you got 18, it's wrong. It must be 18 degrees Celsius. Okay, so, and now, your weather station is also accompanied by precipitation, which will be between these two. It can be drizzle, rain, snow, showers, thunderstorm. In this case, it's rain. And then wind direction, right? Now this wind direction, showing you there, right? So that's very important. You know that's easy. That's showing northeast, right? And the wind speed, yeah. Remember the long lines, 10 knots, and the short ones, 5 knots. So that is very, very important that you should know that. That is your basis of this. Then you must also know your synoptic weather map features. All right? This is what your synoptic weather map looks like. All right? The first thing that you must know, these lines are called isobars. All right? Isobars. Lines, they connect places with the same air pressure. Right? These are your isobars. Right? You must know the L, all the L's means low pressure, and the H's means high, no, that's not a high pressure, that's an H here, a high pressure, right? Here's in South Atlantic. Okay? No, it is the Indian high pressure shown here. Now, what's important here, grade 10s, is that they don't need to put an L or an H there, right? You can work it out. If you ever look at this, here you've got 1008, 1012, 1016, can you see that the values are increasing? Now it's getting higher, so that will be a high pressure. All right? And here it's getting lower, so that will be a low pressure that we find here. That's very important. Your isobar interval is a difference in value between two isobars, right? That is 4 hectopascal. Again, the unit of air pressure, hectopascal. You can't only say 4. You get a question in the exams, what is the isobar interval on the map? And you write 4, immediately no marks. 4 hectopascal. Okay, right. This is a tropical cyclone, all right? Here you've got your coastal low. Here you've got your South Atlantic high pressure, South Indian high pressure found here. And here at Port Elizabeth, the weather at Port Elizabeth, they can ask you, okay, there's a weather, what is, the same thing, what is the dew point temperature, what the temperature, what's the direction of the wind, all those things. You must be able to say that. And this that we find here, this is a cold front. By now you should really know that these things, if you look at the weather during the evenings, weather forecast, you'll see most of these things. Just remember they use other different symbols that we use on the synoptic weather map. Okay, now let's have a look at a few questions regarding the synoptic weather map. The first question here, does the synoptic weather map here show summer or winter conditions? Give 2 reasons for your answer. Now, grade 10, that question is usually the first question in the exams when it comes to synoptic weather. The first thing they ask you, listen, what summer or winter, what season? And when you have a look at this, it's very important that you must look at the temperatures, right? Have a look at the temperatures here. Look at them, 29 degrees, 30 degrees, 32 degrees, right? So your temperatures are very high. That's very important that would be an indication, right? Then, of course, you only do tropical cyclones in grade 12, right? But it will be nice if you know that tropical cyclones also usually come in the summer. Okay. So that is definitely a summer one. Okay. The next one. Have a look at that. These things are just things that are examined. If you look at the previous slide again, here's Luderitz, right? And all that I did on the next slide was that I actually enlarged the weather station at Luderitz. And they say, give the following with regard to the weather station at Luderitz, right? And all you need to do is to write down everything. Look at the wind speed, 35 knots, 10, 20, 30, 35 knots. Air temperature, 24 degrees Celsius. Dew point, 13 degrees Celsius. Okay? So see that you know these things. You must know your weather station. You must know your weather station. You must know the things used, the symbol used there. Otherwise, you can't interpret this. So please make sure that you know all the stuff. Right. Is a high or low pressure? Give a reason for your answer. I think I've done that already when I looked at the characteristics of the of the weather map. Have a look at this. What I've done here, I've completely taken out the H here. So, yeah. Look at this. It's increasing in this direction. 1008, 1012, 1016 is getting higher. So that would be definitely a high pressure. In the same year, 1004, 1096. Can you see it's getting lower as you move towards the center? And that means that would be a low pressure. That's all you've got to do, right? Now, grade 10's high and low pressures. It's going to be very important for you next year, right? When you are really going to look at high and low pressures, what happens at a... Don't do this year, the winds and what really happens there. But what you as grade 10 must be able to do is to identify, is it a high pressure or is it low pressure by means of the isobars, right? Make sure that you know all that stuff. Okay. Here's an interesting question. Explain the difference in air temperature between Maputo and Lüderitz. There's Maputo and there's Lüderitz. Let's have a look. Have a look at this. All right? Now, that is what the air temperatures are. 24 degrees and 30 degrees Celsius. I've just enlarged it there that you can really see the difference in temperature. Now, what's important is that line that I've drawn now. You will see that they are more or less the same distance of the equator. So you cannot have an argument by means of latitude. That's not the thing. But what you really know is when you have a look at this, then you should know the following. You should know NB, the ocean currents, right? You should know that the warm Mozambique here and the cold Benguela there, they are responsible, this one, for increasing the temperature for the high temperature here, and the cold Benguela here at the west coast, that it's decreasing or lowering the temperature there. That's very, very important that you should know that. Right? Now, what I've got here, and this is very important, the integration of content with a synoptic weather map. Can you remember we integrated altitude previously with the topographic map? Now we are integrating here ocean currents that you've learned in the content with your synoptic weather map. Greetings, please at this early stage, as I've said, as you are at the beginning of the final phase of your high school, please get to know these things now already, right? Get the skill to integrate the content with the different maps. It's going to become more and more as you progress. Grade 12 is going to be even worse than this. So while it's easy, why so many marks, too many marks are spent on this, awarded to this? You must see that you know the skills, that you can do these things. Right, following question. Look at this. Explain how the type of rainfall associated with a cold front on the synoptic web is formed. Now look at that. What have we done now? Again, we have integrated rainfall with the cold front here. In other words, here's a cold front here, right? And if you have a cold front here, this is the thing that I've just explained to you a few minutes ago. So you must know this, grade 10s. You know, I always say that when it comes to map work, you must know your work thoroughly. Because here it has to do with the application of your map. And if you have a look at this one, if you didn't see this cold front here, what was the chances that you would be able to explain that? Right? So this is very, very important that you must be able to do that. Now again, grade 10s, this was our last topic. So let us just have a look at what you must know. You must know this when it comes to synoptic weather maps. You must know what is an isobar. You must know what is the isobar interval on synoptic weather maps. You must know what are the symbols used on synoptic weather maps. You must know what is a low pressure. You must know what is a high pressure. You must be in a position to draw a station model. You know, your teacher can give you information and say, okay, this is what the air pressure is, this is what the dew point, the air temperature, is the dew point temperature, this is the wind direction, this is the wind speed, this is the cloud climate. Draw that thing, right? You must be able to draw that. Very important. And then, can I apply content on synoptic weather maps? I've shown you when it comes to your frontal rainfall, right? Or cyclonic rainfall fall. Can you apply that? When it came to your ocean currents, how many of you really knew that the answer was them? So grade 10s, this brings us to the end of our revision. I would just like quick summary of everything. Remember, we looked at the atmosphere. We looked at the different layers. You must know that. You must know the names of the layers. You must know the ozone layer. You must know the impact of that. Then you must know the warming of the atmosphere. The four types, the four factors influencing warming, very important. You must know global warming, the moisture in the atmosphere. We looked at different clouds. You must know the characteristics of each. You must be able to identify it. All right? And then we looked finally at the synoptic weather map. You must know, as have you seen, this is actually the climax of your atmosphere, because many of the things that we have done previously in the content comes back to you in your synoptic weather map. So please see that you know your work. So grade 10s, thank you for being with us. Thank you for going through your work. Thank you for taking your revision seriously. And please look out for your revision booklet. Get that thing. Work out all the everything. Most of the things that I've done with you does appear in a revision booklet. And I'm sure that if you have looked at our video later on, and you have your revision booklet, it will make it much easier for you to understand and apply your knowledge for your atmosphere during the first quarter. I hope to see you during the rest of the year. The second quarter, we will look at geomorphology, and then the other topics of the third and the fourth quarter, we will do in one lesson later throughout the year. And remember, study, and understand, and please think in pictures, think in images, like I've shown you, and then you will definitely be successful in geography. Till next time, see you later. Take care. Bye-bye.